Welcome to Spaceverse, your portal to cosmic adventures. A cosmic drama unlike anything we've ever witnessed has just unfolded, one where a planet didn't merely brush past its star or get vaporized slowly over eons. No, it fell straight into the heart of its parent star. Thanks to the keen eyes of the James Webb Space Telescope, astronomers have caught this dramatic moment, and what they found challenges long-held assumptions about how these stellar interactions really play out. Let's set the stage. In 2020, the Zwicky Transient Facility at Palomar Observatory in California spotted a distant star flaring up unexpectedly, getting significantly brighter than usual. The star, now labeled ZTFSLRN 2020, is located around 12,000 light-years away from Earth. At first, scientists weren't sure what they were looking at. It was a curious optical brightening, but what made it even more mysterious was what archival data from NASA's NEOWISE infrared telescope revealed. For a full year before that bright flash, the star had already been glowing brighter and brighter in infrared light. Something was happening, something big. Astronomers initially suspected that this was a red giant, an old, bloated version of a sun-like star, engulfing a gas giant planet that had strayed too close. That explanation made sense at the time. After all, red giants are known for their massive, expanding atmospheres. They often consume inner planets as they grow. It's a natural endgame for many solar systems. But the James Webb Space Telescope would soon flip that theory on its head. A team led by Ryan Lau of the Noir Lab in Arizona took a closer look. They used jwst's unparalleled infrared vision to study the scene in greater detail. What they found was not what anyone expected. ZTFSLRN 2020 wasn't a red giant at all. In fact, it was still a fairly ordinary star, just 70% the mass of our own sun. And that changed everything. Because if the star wasn't in a dying phase and expanding to swallow nearby planets, then the planet must have fallen into the star all on its own. This realization sparked a new line of inquiry. How does a planet fall into a star without any help from stellar expansion? As it turns out, this is a phenomenon astronomers have been chasing for years. You may have heard of hot Jupiters, massive gas giants found orbiting very close to their stars. But what you might not know is that these planets didn't form there. They started much farther out, then migrated inwards over time due to complex gravitational interactions. Now imagine a hot Jupiter taken to the extreme, pulled in just a bit too far. Eventually, gravitational forces win out. The planet gets close enough that the outer layers of its atmosphere start grazing the star's surface. From there, it's a fast, fiery descent into oblivion. As MIT's Morgan McLeod puts it, the planet, as it's falling in, started to sort of smear around the star. Gravitational shear stretches and distorts it. Eventually, the planet plunges into the star's gaseous layers in what scientists call a splashdown. And this splashdown doesn't go unnoticed. The star, now agitated by the sudden deposit of mass and energy, reacts violently, ejecting a plume of gas into space. As that gas cloud expands and cools, it begins to glow in infrared. That's the glow NEOWISE picked up. And it's what eventually led astronomers to look closer. But jwst didn't just confirm the infrared glow. It discovered something else entirely, something no one saw coming. Surrounding the star, nestled close, was a disk of molecular gas. Not a chaotic mess of expelled material. A structured disk, one that looked astonishingly like a mini protoplanetary disk. In other words, a region that under different conditions might actually give birth to planets. Now, to be clear, no one's saying that planets are forming there right now. As Colette Salick of Vassar College put it, I find it hard to believe that in the aftermath of an engulfment, we are witnessing what appears to be a region conducive to planet formation. And yet, there it is. Where did this disk come from? Likely, it's made of part of the planet that was swallowed, the material that didn't escape into space entirely, but instead fell back and formed a rotating structure around the star. This discovery raises a flurry of new questions. Could planet-star collisions lead to temporary planet-forming conditions around older stars? Could this be part of a cycle in some systems? Could it explain unexplained disks we've seen elsewhere in the galaxy? The implications stretch beyond this one event. JWST's success in observing this cosmic collision paves the way for future discoveries. And with telescopes like the Vera C. Rubin Observatory and NASA's Nancy Grace Roman Space Telescope coming online soon, we can expect to find many more of these stellar mysteries waiting to be unraveled. What's happening here may not just be a rare spectacle, it might be a common, yet hidden, chapter in the story of planetary systems. Let's step back for a second. For decades, our models of planetary evolution largely focused on formation and stability. A young star surrounded by a protoplanetary disk. Planets forming, migrating a bit, and eventually settling into stable orbits. But this story introduces a different kind of ending, one that is less stable, more dynamic, and perhaps more violent than we once imagined. Instead of peaceful orbits lasting billions of years, some planets may be doomed from the start, destined to spiral inwards, ending their lives in the very furnaces that birthed them. And this isn't just about distant stars. Events like the one seen with ZTFSLRN 2020 offer a chilling window into our own solar system's distant future. Billions of years from now, as our sun evolves and expands into a red giant, it too may engulf Mercury, Venus, and possibly even Earth. Watching this process unfold elsewhere helps us understand what that might look like and when. More broadly, this event showcases just how transformative JWST has already been for astronomy. Without its ability to see in the infrared, we wouldn't have detected the early signs of this collision. We wouldn't have seen the cooling gas cloud. And we certainly wouldn't have spotted the disk, a structure that raises more questions than answers. It's this level of detail that sets JWST apart. It's not just about seeing more stars or spotting new galaxies. It's about rewriting the narratives we thought we understood. About planetary migration, system evolution, and even the ultimate fate of worlds. It also reminds us that the universe is not a static, peaceful place. It's filled with movement. Chaos, collisions. And it's in these moments of destruction that new science is born. This one planetary death has already reshaped our thinking. And it's just the beginning. Because if one planet can fall into its star and leave behind a structured disk of molecular gas, then surely there are more out there. Waiting, unfolding, right now. And now we know how to find them. The paper detailing these findings was published in the Astrophysical Journal on April 10th. It represents a significant leap forward in our understanding of late-stage planetary evolution and the sometimes violent ends that await many exoplanets. As we continue to observe, study, and learn, one thing becomes clear: the universe has many more secrets to tell. And thanks to the James Webb Space Telescope, we're finally in a position to listen. If you enjoyed this cosmic journey, don't forget to like, subscribe, and tap the notification bell so you never miss a moment of deep space discovery. This is Spaceverse, bringing the wonders of the universe a little closer to home. Until next time, keep looking up.